With the orbital missions of Mercury now complete, and several objectives to accomplish before the moon missions of Apollo, NASA's answer was Project Gemini. A two-man spacecraft not much bigger than Mercury, but with a far more ambitious flight plan. This new spacecraft was far too large for the Atlas rocket used with Mercury, so NASA would turn to the Air Force's new Titan II missile. Originally designed to carry a nuclear payload, it would be outfitted with a Gemini spacecraft long before one would ever receive a nuclear warhead, and fortunately for the world, it was never needed to launch one. The objectives of Gemini include long-duration spaceflight for as much as 14 days, extravehicular activity, or EVA, otherwise known as spacewalking, rendezvous with another spacecraft at docking. This was essential for the lunar landing strategy of Apollo, for the lander would not only have to find the orbiting command module, but physically link with it to transfer the crew for their return to Earth. Naturally, the Mercury 7 astronauts would get the first seats on Gemini, but even during their Mercury flights, NASA had already added a second class of astronauts, calling themselves the New Nine. For the first manned flight, Gemini 3, America's first man in space, Alan Shepard, would ride alongside rookie astronaut Tom Stafford for a shakedown cruise of this new vehicle. Unfortunately for Shepard, he had been diagnosed with an inner ear infection, Meniere's disease, and was grounded indefinitely. Since the two-man flight crews trained together, removing one crew member also meant removing the other. The flight of Gemini 3 was therefore handed off to another Mercury veteran, Gus Grissom. His New Nine rookie riding shotgun would be John Young, who would also go on to fly the very first space shuttle flight decades later. This first flight would not accomplish any of Gemini's main objectives, but instead would demonstrate the functionality of the spacecraft itself, which had performed even better than expectations. At one point, controversy arose when Grissom had given Gemini 3 its call sign. After his Mercury spacecraft had sunk in the ocean due to the malfunctioning escape hatch, Grissom had called his Gemini spacecraft the unsinkable Molly Brown, in reference to the Broadway musical of the same name. NASA was not impressed and urged him to change the name, to which he responded, "How about the Titanic?" NASA relented and allowed the name to be kept. However, it would only be called Molly Brown after launch, referred to simply as Gemini for the remainder of the mission. NASA had subsequently refused to allow any other astronauts to name their craft, which was unfortunate for the crew of Gemini 4, who would lose the name American Eagle. Much like earlier rockets, the Titan II was a multiple-stage vehicle, and after the propellant was exhausted from its first stage, it would blow explosive bolts separating its booster and firing its second stage. Originally, the mission of Gemini 4 was supposed to be a simple long-duration test flight of 4 days. But after Russian cosmonaut Alexei Leonov's successful EVA on Voskhod 2, NASA had pushed forward its own EVA plans several missions early. The two men who had trained for this were rookies Jim McDivitt and Ed White, becoming the only new nines to be pushed ahead of Mercury vets. Ed White's excursion outside the spacecraft was an amazing experience for him, after which he would later comment that getting back inside was one of the saddest moments of his life. After completion of the EVA, McDivitt and White would complete their 4-day endurance mission before returning to Earth. As we continue to round out our orbit, once again, I do wish for calculations, but flying by the seat of your pants is more fun. After reaching orbit, the spacecraft would separate from its booster stage. The spacecraft itself, which is shrouded by darkness, unfortunately, would consist of the familiar bell-shaped design, along with a white cone-shaped service module, providing oxygen, electricity, and propellant for its maneuvering thrusters. After completing its first orbit, the men inside Gemini 4 would make the first attempt for a rendezvous in orbit. In this case, they would attempt to rendezvous with their spent booster stage. But this proved difficult, as maneuvering in orbit was very counterintuitive for a trained astronaut, or rather, a trained pilot on Earth. Traditionally, instinct would have you fly directly toward your target, but that is instinct within atmosphere. For as you increase thrust to maneuvering closer, you actually increase your relative velocity. Now in this case, on Gemini 4, the two parts were miles apart, and on the other side of the Earth. So the spent booster stage was actually behind Gemini, not in front. And as they attempted to move closer to it, they would actually find themselves moving down and away. This is because when you increase velocity, you actually increase your orbital path. As we see here, the apogee starts to rise. Or in this case, firing away from their direction of flight would decrease their orbital path, which is why they were moving down and away. Also, the booster stage was leaking propellants and moving erratically, and only had 2 running lights, making it very difficult to determine its orientation. They had no functioning radar for rendezvous on board, so they had to rely entirely on eyesight, and judging distance was difficult because the judged distance differed between the 2 men by as much as 500 meters. After the completion of Gemini 4, it would be the crew of Gemini 5, Mercury veteran Gordo Cooper, and rookie Pete Conrad to attempt an even longer endurance test of 8 days, testing out the new fuel cells. Rather than traditional batteries, fuel cells use a chemical reaction of oxygen and hydrogen to produce electricity. While things were a bit tricky throughout the flight, the overall mission was a success, and the two had returned safely, with some of the most amazing photographs of Earth yet taken. With the mission complete, Gemini would shed its service module, leaving a second ring with a small set of engines for retrofire. After fuel was exhausted, this module would also be jettisoned, exposing the heat shield for the fiery plunge through the atmosphere. The bell-shaped spacecraft, similar in design to Mercury, function much the same way during re-entry. The convex shape of the heat shield, not only shedding off the heat of re-entry, but providing a small amount of lift to help guide the craft toward its target. The heat shield, made of ablative material, would slowly burn off as it shed all of the kinetic energy from its velocity, shielding the astronauts inside from the excessive heat. Unlike the Mercury spacecraft, Gemini would not actually shed its heat shield. Back in Mercury, behind the heat shield was an inflatable landing bag that would help the spacecraft keep buoyancy. But for Gemini, this was not needed, as the parachutes deploy along its topside axis. So instead of the astronauts landing on their backs, they would land sitting straight up. And buoyancy would be provided from the area beneath them, as they would essentially be sitting in a small boat. Unfortunately, this cannot be demonstrated here, as this particular mod in Kerbal Space Program does not include the longitudinal parachutes. It should also be noted that the instrumentation aboard Gemini was slightly different than other spacecraft of the time. It would most closely resemble the instrumentation of an aircraft, including the artificial horizon and the translational controls. These controls were actually designed by Mercury astronaut Gus Grissom, and he designed them specifically with pilots in mind. Unfortunately, they had to completely redesign the spacecraft externally, as it was designed specifically to fit around his tiny frame, Gus just a shade under 5 feet. With the early missions of Gemini a complete success, it would now be time for NASA to focus on the more ambitious flight plan, particularly rendezvous and docking. For this specifically, NASA had commissioned a special target vehicle called Agena, which would dock with the docking mechanism in Gemini's nose, which is jettisoned here to expose the parachutes. As the parachutes deploy and Gemini begins its final descent, here is where we will say farewell. For in the next video, we will start to cover the Agena target vehicle, as well as the missions of Gemini 6 through Gemini 12. Thank you for watching this program of KerbalOdyssey, You're on SciMax TV, the sci-fi view of the universe.